Here you can see my ground raster in gray and the raster to merge in white and black. Maybe you see it before, the raster to merge is not aligned with the ground raster. The shift is about 0.5 meter to the south and to the east. Because of this, I get different results from r.patch and from the raster calculator. First, I like to show the results of r.patch. This is my raster to merge with 50% transparency. In the merge operation with r.patch, the smaller raster will shift to the west and north to fit in the cell centers. The outside cell line at the north and west will delete it. This is the result, displayed with the original raster to merge layer and arrows in the shift direction. I also displayed some deleted cells. On the other hand, the shift with the raster calculator is in the east and south direction. Here's a screenshot of the final result. The shift is displayed by arrows again. I like to move the raster to merge 0.5 meters to the west and to the north to align the cells with the ground raster. The first step is to display the coordinates of the cell centers to calculate the shift. I use a grid to do it. Click on Vector, Research Tools and on Create Grid. Change the grid type to rectangle and the grid extent to your ground layer. The resolution of the cells are 1 by 1 meter, so I don't need any more changes. Now I do the same with the layer to merge layer. Change the grid extent by choosing your layer to merge layer. Make sure the created grid fits the cells of the raster layers. If not, you have to change the option until it fits. I will rename the grids to distinguish them. Now I will create centroid points on both grid layers. Open the processing toolbar and type in Centroids. Choose Centroids under Vector Geometry. Choose one of the grid layers and activate the option Create Centroid for each part. Choose the second grid layer and do it again. Open up the options of the centroid layer, go to Label and type in this expression. It will show the x and y coordinate of every centroid. I copy the label option and pass it to the centroid layer of the smaller raster. Now we have to subtract the coordinates in x and y direction to calculate the shift. Search for Affine Transformation in the processing toolbox to test the calculation. The shift in my case is minus 0.5257 in x and 0.5191 in y direction. It worked. The centroid points are aligned off each other. I will convert the raster to merge layer into a vector layer. Click on Raster and Conversions, then on Polygonize, Raster to Vector. Choose the right layer and the band and click on OK. It is time for the Affine Transformation again. Choose the right layer and type in the calculated shift in the step before. Finally, I convert the vector layer back to a raster layer. Click on Raster, Conversions and on Vector to Raster. Choose the transformed layer, the right field, size, extent and no data value and click on OK. Sometimes the conversion raster to vector creates big connected cells with the same high information. It happened when the difference in the high is very low on each cell. Like in my example, I get 3 big connected cells back. The high of the example is about 75 to 76 meter and changes only in the decimal area. There's a trick to deal with it. Open the raster calculator and double click on the raster layer, multiply it by 1000. Do the raster to vector conversion again. Now we get an integer with 5 numbers of the high in the vector layer. I will convert it again into a raster file. To get back the original height information, open the raster calculator and divide the layer by 1000.